Hey guys, so today we are going to start with our water unit. So we're going to be talking about water quality, and then towards the end, we're going to be talking about fishing as well. So to start off today, we are going to introduce this by talking about kind of where our water comes from with watersheds. So, just looking at specifically the state of Wisconsin, we have a really, really rich water history, which seems kind of weird to us because we're just used to it, but not a lot of states have the access to fresh water that we have with the Great Lakes, all of our rivers and streams, more lakes than Minnesota, which I always think is hilarious. So, if we're looking at Wisconsin, there are 13 to 15,000 lakes. It depends who you ask because there are some publications that define a lake as so many acres, and then for some that would be a pond. So it's somewhere between 13 and 15,000. And then we also have 84,000 miles of navigable rivers and streams as well. We have a ton of water. This is really unique too. So in 1787, there was a law passed called the Northwest Ordinance. And in that law, it stated that the navigable waters leading into the Mississippi and St. Lawrence and the carrying places between the same shall be common highways and forever free. There are a lot of states where water is not public and you can actually privatize parts of rivers, streams, lakes, ponds, all of that stuff. In Wisconsin, because of this Northwest Ordinance and the fur trappers that were in Wisconsin that knew that they needed these waterways to get around, they made everything public. And that is still law today, which I think is pretty cool. So when we are looking at Wisconsin and all of our watersheds and everything like that. Let me just move myself up here. This map here from Paddle, Wisconsin, this is basically a main map of all of the really, really big rivers and streams that are navigable. So that means that you can easily get a boat or anything like that through it. And by boat, a kayak or a canoe, right? So we're not taking like big freight liners through a lot of these waterways. But then when we look at the other map that has all of the blue and green splotches on it, this is a map of watersheds. So what a watershed is if rain basically falls in that area, where is that raindrop going to go? So if we look by us, we are actually right on the border of two watersheds, the Sheboygan and the Milwaukee watershed. So if you look at the Sheboygan watershed, and then we kind of look over at this map here, any little raindrop that falls within that area, because of how the topography of the land grows and rivers, lakes, streams, it will kind of go up here to filter out into Lake Michigan. So it will go into one of these waterways. Here in Random Lake, we are actually in the Milwaukee River watershed. So if a raindrop falls in Random Lake, it will then go into Silver Creek and then the North Branch of the Milwaukee River and all through. And then finally, it enters Lake Michigan way down here. So water drop up here, where my little cursor is going, it's going to flow all the way down. And that's what your activity is going to be about today, is looking at our specific watershed. So some of these watersheds are very, very large, and some of them are a little bit smaller, like this Southeast watershed. It is pretty tiny compared especially to the lower Chippewa watershed. So this seems kind of stupid, but it really, really ties into watersheds. All water flows downhill. So water obviously cannot flow uphill. There's no such thing as an uphill waterfall. So every single drop of water that falls will either percolate, evaporate, or run off. So looking at some definitions of these, percolation is the seeping of water into our groundwater system. So soaking into the dirt, becoming part of the aquifers that are underneath our ground that we get fresh water from, especially if you have a well at your house. Or water can evaporate. So if water falls in the ground, it's going to go through the water cycle, it's going to evaporate back up into the air, become clouds, go into the atmosphere. Or that water is going to run off. So water is going to flow downhill following the path of least resistance to major reservoirs, lakes, ponds, wetlands, oceans, all of that. So if you think about runoff, this is becoming more of an issue because there's always going to be natural runoff in areas. However, when we are stopping water from percolating into the ground with concrete, asphalt, different things like that, we are getting more runoff, and that water is picking up stuff along the way that is not necessarily great for our water. So I'm sure you guys have all seen a water cycle picture like this before. So we have evaporation, goes up into the atmosphere, condenses into clouds, falls down as precipitation. It will then run off into rivers, lakes, and streams, and then start that whole cycle over again. Okay. So, some things that can actually stop this flow of water, just like I said before, asphalt and hardscapes. So, parking lot, buildings, all of that stuff can stop the infiltration and percolation of water into the ground. Infiltration and percolation, they are technically different things. I kind of use the words interchangeably because they're very closely connected. So, infiltration is just like when water initially goes into the ground, percolation is when it actually goes into the underground aquifers. Landscaping and grading. So if you just think about like the construction that's going on our school right now, they are moving the land in such ways to make water flow where it should, because if you landscape and grade poorly, then you get big dams of water all over the place, and that can be really bad for your building foundation or any other thing like that. So when you are doing landscaping, if you own a house one day, you have to be really, really careful about where you're moving dirt, because physically moving that land can change the flow of water and it can actually damage your house. Plant life as well can also stop the flow of water. So changing the plants in an area can change how much water actually makes it into that groundwater system. This can be really good in certain areas. So if you think back to like the soccer field behind school, it's just always wet back there. And that's because this whole school was actually built on a wetland, built on a swamp. And the type of grass that we have, the roots don't actually go deep enough or use enough water to soak up all that extra water that should be in the watershed. Basically, it should be in that wetland. So a way that we can have plant life stop water from gathering on the surface is to have native grasses and forbs that are going to have really, really deep root system that need a ton of water, different things like that. Okay. So looking at some of these things, we do have some solutions to help water get back in the ground that I think are just the coolest. So we actually do have technology called permeable asphalt or permeable pavement. There are a couple different ways to do it. One way is kind of in the schematic right here, to put concrete pavers with permeable joint material. So this picture here with all of the green stuff in between is what it actually looks like in practice. So you would plant a moss or a short grass or something like that between all of these pavers. So when water falls, it will roll off of those pavers and then soak into the soil, so we don't get big puddles on our asphalt, and it's not able to like pick up salt and other things like that that are bad for our groundwater system. So underneath that, we have different rocks and open graded reservoirs. And then sometimes we can actually have a drain underneath as well to shunt that water where we specifically want it to go. Because if you look at this picture here, we have like an asphalt road. So when water falls onto there, it's going to run off into the gutter, but it can also run off into the system where it can then soak into the ground where we need it. There are other permeable asphalts that are porous to water. Some downsides of this is that they're a little weaker and they have to be replaced more often. So like highways and roads do break down over time. I'm sure you've all experienced the potholes and things like that. This potholes faster. Ecologically, it'd be awesome if we could make all roads like this, but for our human existence, how we exist now, it just wouldn't be possible. But it would be something that would be good for like a driveway at your house or anything like that. So some other things that we can do to help get water back in the ground to eliminate that runoff that can cause erosion is by eliminating monocultures. So a mono means one, culture refers to agriculture. So a monoculture would be like a field of corn. The root systems in those fields are not conducive to absorbing mass amounts of water. So when we have differences in these plants, the roots of those plants are actually what holds that soil. So when mass amounts of water fall, they don't just wash soil into rivers, lakes, and streams. So having high biodiversity is really, really going to be great for these root systems, holding that surface, oh my gosh, words are hard, holding all of that surface soil in place and absorbing some of that water. Another thing is by maintaining buffer zones around streams and rivers. One example of this that you can actually see around us is if you go across the road from school, across 144, there is that kind of wetland there. That's actually what the land that the school was on used to look like. With all of the forbs that are in there, the trees, whatever, they can absorb a lot of water. And they also hold that soil there in high rain events. Whereas if you look further down 144, when Silver Creek crosses over again, and then there's part of the North Branch of the Milwaukee River, and there is farm field all around that. Whenever we get really, really high rain events, those fields always flood because there's not a big enough buffer around that stream system to actually absorb a lot of that water. So maintaining these buffer zones around streams and rivers of native vegetation is really, really important for flooding. We can also have deep-rooted plants to prevent erosion and something called a rain garden. So with a rain garden, if you have a downhill slope in your yard that would always get a puddle, you can plant plants there that love that high water system. It can create a diverse habitat for lots of different animals, and it can help soak up that extra water so it can't really percolate into the soil and get at the foundation of your house. So this is where some smart landscaping can kind of come into play a little bit. So these are just some images of what I was kind of talking about with the streams along Highway 144. So if we have some intact wetlands, those areas can help absorb water and allow it to not run off into this river. When we destroy these wetlands in order to build houses or fields or anything like that, that water has no place to go and it's going to run off and then it can flood towns. This is why we are getting more floods now more than ever, because we have gotten rid of so many of these wetlands, created fields and subdivisions, and put schools on top of wetlands. We get more flooding now in all over the world, all over the United States, especially because of destroying these watersheds. So what you guys are going to do today is a little assignment that I call A River Runs Through It. What you are going to do is go on Schoology. I do have a hard copy of the assignment for you, but you are going to go on Schoology and use oh my gosh, words are hard. Once again, use a website called The River Runner by Sam Lerner in order to look at some watersheds. So what you guys are going to do is go into Schoology and you are going to open the folder for Unit 7, which is water. The notes that I just went through are right here. And in the week 1 folder, you guys are going to click on that. This is the worksheet. You guys have a hard copy. Please answer all the questions on the hard copy to turn them in. But here we have the link for the River Runner Simulator. So you guys can open that up in a new tab. And what this is basically a map of the United States. And anywhere that you click on the map, you can see where that raindrop would actually end up, which is pretty cool. So if we just go here, I click on this random spot, Grand Prairie, Texas. Look at that. So what it does, and I'm on top of it, it will show me where that water drop is actually flowing in order to get through its watershed and its final destination. And then it takes you through it. It's kind of satisfying and fun to watch. So that is what you guys are going to be doing for this part of the assignment. And then if you guys go back into Schoology, you are also going to use this runoff simulator. So you're going to open this up in a new tab. And with this website, to answer the questions on here, we have a little slider over here. So precipitation for a 24-hour storm event. So like if it would rain all day. So if you move this up and down, you can see up in the, I can't point, up in the corner here, this is how much precipitation we're getting. So 21 centimeters of precipitation or 1 centimeter of precipitation. It is showing me how much of that is evapotranspiring, so how much is coming off of trees and going into the atmosphere, how much is infiltrating, so how much is going into the ground, and then the red is runoff, so how much is actually running off. And then I can actually change my stuff here, so I can do developed high intensity land. So that would be like a factory or something like that. I can do a pasture or hayfield. So what would it do then? Crops versus wetlands versus development, anything like that. I can also change the soil groups. So low infiltration soil, moderate infiltration, high infiltration soil. So you're going to go through the simulation with the questions that are in your packet as well. So that is what you guys are doing today. Awesome. Thank you guys.